Hi everyone, we are back with APIM Hotrod, a new episode number 12. Hey Stefan, how are you?
Hey Massimo, fine and you?
Very good. Summer is coming or already summer is
Oh, yeah, I don't know. Will it start really one day in Belgium? I don't know, but let's see. At least,
yes, yes.
well, even today is not great so far, but let's
Mm.
see. Let's see. It's
Yeah,
not
sun is
raining. It's
shining,
already
so
good.
yeah, yeah. Full of energy, full of energy.
Yeah,
That's
yeah.
wonderful. Okay, guys, today what is our topic? What are we talking about? We will let me go here always to our polar star, your API management architecture map. We will talk about high availability, global high available solution, regional high availability. So, which kind of solution and we can put in place with API management to have something resilient, something that is enterprise grade, something that is really can protect our customer with a regional or a global failure, these kind of things.
Yeah,
So, in
indeed.
order to help this discussion, Stefan, I'm bringing into the stream your screen. Okay,
Yeah, perfect. Yeah, good. Thanks, Massimo.
here you
Yeah,
go.
so we see my screen and so we see if I move, so it's perfect. Yeah. So basically, just before going through a design, just a quick recap. This is not specific to APIM, but of course, APIM can leverage this as well. So big difference between availability zones and regions is that availability zones are data centers within a single region. So physical data centers, let's say autonomous data centers, and this is meant to resist against local disasters, so fire, flooding, that kind of stuff, and not a massive, let's say, disaster, which could actually impact more than one data centers of a single region. If you take multiple regions, then they are really far away from each other, and then, of course, normally a single disaster should not affect both regions at the same time. Right, so that's the big difference between those two concepts, which of course are not specific to API management. But it appears that API management is both able to actually leverage availability zones and also multi-regions. And so you can really build robust, let's say, solutions. So, having said this, if actually I zoom a bit on the, let's say, high-level design here, uh, this is inspired from a real-world project where basically the customer had a global API platform. So it's meaning, let's say, serving, let's say, marketplaces all over in the world and mostly on three continents. So I actually crafted this diagram here. I'll zoom in a bit later. And only representing two continents here. But of course, if you know how it works with two, then you can understand how it will work with three. Um, and basically, this is an active setup. So if we actually zoom out first, just to see the big picture, we can see that basically I have two regions here. So this is one in Europe, one in US in this case. And of course, if I zoom in one region, I'll have the same on the other region. And because it is active, then of course I expect that both regions will take some part of traffic, and of course then will actively contribute to the let's say solution, let's say, and ingesting traffic. So if I zoom in a little bit and maybe start with the, let's say, entry point. Typically, when you have a multi-region setup, you try to always use front door. So there are two real solutions. Let's say in Azure, you have front door and traffic manager. Front door is of course a good choice because, especially for API traffic, because of course front door has something called WAF, so you can associate WAF policies, so web application firewalls, and of course in security, if you try to build something secure, a good, let's say, good practice is to try to block illegal or malicious or suspicious, let's say, calls as soon as possible. So then front door is typically the entry point. Front door is also has a global view, let's say, so it's a global service, so it's not sensitive to a region failure. So itself would still be running. And so, in the goal, typically, when you have front door as the entry point, the default behavior we expect is that if you have an EU user, it would be sent to the EU backend, just because this is the closest, let's say, location with regards to the user and the fastest. So typically, the default algorithm is latency based, and of course, if you're in EU, it makes sense that typically the EU backend is faster than the US one. Of course, it's not a guarantee. So if you have a latency-based backend, you might have an EU user still going to, let's say, US and vice versa. Should you have an issue, let's say, on the US side, I mean, an issue, just some extra latency doesn't mean that it's down. And of course, when you have an active setup, you expect that if one region is failing, then of course, automatically the other region is already up and running to absorb the load of the region that was just failing. So typically front door, then there are two choices here. So if you take APIM as a backend, either you use, as I do here, the gateway, the regional gateway endpoints, right? So if you have API management, one gateway unit in West Europe, one in, let's say, US, either you define them as part of your origin group, like I did here, either you could actually target the single, the FQDN of APIM, that is the global name, if you want, of APIM. So
Okay,
if you do,
Stefan,
yeah,
on
yeah, go
this,
ahead, please.
sorry, because maybe you need to zoom in.
Ah,
This is
yeah,
very clear what you said, but maybe not
yeah,
for everyone. Can you
okay,
just take 1 second to explain the difference between the single endpoint that
yeah,
API Manager have and
yeah.
the DNS of the regional gateway?
Yeah. So basically, if you have API management here, right, and you have enabled two locations, so two regions in this case, you will have regional gateway units. So one in this case in North Central US and one in West Europe. So at the level of front door, you might decide to use those regional gateways, right, the FQDNs targeting those regional gateways as part of your origin group. Either you have this, either you can actually simply refer to the main, the single FQDN that represents your APIM instance. So you would not have North Central US, you would have in this case conference apim.azureapi.net. If you do this, then it's actually API management itself that will be in the driving seat to load balance the traffic across the regional gateway unit. So while this is, that's why it works, I still prefer this approach here, because with this approach, you really let front door decide where to send traffic. So as I said, by default, typically you have a latency. If you choose a latency-based algorithm, it will always send it to the fastest region. So typically, if you're in EU, it will then go to EU, and in US, it will go to US. But if you have to enforce some rules, like for instance, say that you enable a new country for which you don't have a region yet. Say that here we have those two, and tomorrow I have a country in the Middle East, for instance, but I've not enabled the Middle East region completely, right? And maybe by regulations, I would be forced to send the Middle East traffic that comes from Middle East to always to EU. Maybe because I have some regulations. With this setup, I can do it because I can always add the Middle East gateway. I would not even have a Middle East gateway unit in this case, but I can add a rule to say in the WAF rules, if traffic comes from this country, then send it always to West Europe. If you say, no, you have the single API management endpoint, then it's APIM that will take the decision, and you will not be able to influence where APIM will send that traffic. Okay, so
Yeah,
that's why, yeah,
yeah, I love your approach. Also, it gives you, it allows you, if you want to roll out this new region in a progressive way, you might have this region out of rotation of your load
yep,
balancer, just using a jump box or whatever to do the validation that you want, and then bring it into rotation by doing a change
yeah.
in front door, right?
Indeed. So actually, when you use this, then front door is really in the driving seat, and so you can decide, let's say, with any type of rules you want, to indeed dictate how front door should forward traffic to the backend. Indeed, for testing, that could also be a good thing. So if you enable a new region at the API management level and you want to test it first, you could say, okay, you only let's say if let's say traffic comes from let's say your own data centers, then you would route it to that backend explicitly so that you can test. else you would route automatically to the two others. So basically, that's the advantage of having this, right? So WAF, we mentioned that, so that's also why you have typically a front door, because you could say, okay, but APIM itself is a regional, is a, let's say, can be multi-region. So why do we need front door? I could also expose APIM directly to let's say to internet, and let APIM decide. But APIM itself does not have a WAF. So typically, you want to enforce, let's say, security best practices. You want to have a web application firewall in front, and of course, your front door could be shared for other stuff as well. So you don't need to dedicate it to that scenario. You might reuse that for even UIs and so on, non-API traffic. So that's one reason why you take front door, a WAF, just to make sure that you let's say have a robust security posture. Um, then if we zoom in about what's inside, let's say, a given region, then we have APIM. So in this case, I decided to take Europe as the primary region. And so by primary regions in APIM, it means that the control plane will be in the primary region. So meaning that if West Europe would be down, for instance, my second region would still work, the gateways would still work, but you would not be able to update APIM until the primary region is back, right? So that's a bit, but APIM itself would still work. So
Let's give an
yep,
sorry, Stefan. Let's give an
go ahead.
example here, or tell me if this example is right or wrong.
Mhm.
So if in this case the primary region is down Europe, if I want to scale out or scaling, yeah, let's say up, yeah, out the secondary region, in
Yeah,
this case
yeah,
US, I will not be
yeah,
able to scale out during
indeed.
that period, right?
Yeah,
Is it
yeah,
make
indeed.
sense?
You will actually not be able to change anything about the config, right?
Okay,
You would not
wonderful.
be able to change a policy or whatsoever, right? Because of
Okay,
course that's part of the config, and so that is in the well, actually the data plane of APIM, which is in this case in this region. And so each gateway unit, when it starts, will actually fetch the data, policies, and so on and so on. And of course, it is able to run offline if you want, right? But then, of course, until the primary region is back, then you will not be able to change anything. So indeed, that's something to pay attention to. That's of course automatic, so it's not that you have something to do about it if that happens. That's the default behavior, let's say. No, in that, because I really deployed this for another talk, it was, let's say, a longer talk. But you can also enable zones, right? So you can have a multi-region, let's say, APIM and zone redundant on top of it. So of course that will cost money, but that's, let's say, the most robust a solution that you can have, the most robust architecture, because then not only you could actually resist against a local disaster that would happen only in one region, right? But also you could resist against a global disaster or let's say a regional disaster.
okay.
So
So that means
yeah, yeah,
I can have three
yeah,
units of my gateway in Europe
yeah,
and three units in
yeah,
US. So I have
indeed.
this high availability in the zone and
Yeah.
this high availability globally.
Yeah, indeed, indeed. And so indeed, of course, then the goal here is that you say indeed you have three units, each in a different zone to really make sure that you have this resilience. And so of course across zone. So because of course every gateway unit will talk to backend somewhere. So if you actually let's say have zone redundant traffic or zone redundant APIM, sorry, I also advise to typically try to be zone redundant all the way. So also including in the backend side, just to make sure that because zone redundancy is always active. So the load balancers that you would have in front of here, it's a VM because it's always easy to test. But say that you would have app services or AKS, for instance, for your backend services. If they are zone redundant, typically the fastest location will also be picked up by those load balancers. So if your gateway unit is in zone one, it will often send to zone one as well. If you don't have the same number of zones, then you will inevitably have inter cross zone traffic, which incurs some extra latency, because zone to zone traffic is typically 2 milliseconds. So might look ridiculous, but of course, if you add 2 milliseconds to thousands of calls, at the end of the day, it might actually be quite substantial. It doesn't mean that if you are in zone one, you will always be sent to zone one. Let's say on the backend side, it's just that because it's real load balancing, but it's again trying to pick up the fastest one, right? So typically, you would indeed still try to remain the same zone. So that's something important here today. So that's something to keep, of course, an eye on for the future. But today, if you take API management and you put it behind front door, the API management still needs to be public. Okay, so the inbound, so you still need to have a public VIP. So you can be VNet integrated, but in external mode. That's an important thing. And of course, you can lock down the traffic to front door by combining two things. So one is making sure that you lock down the front door service stack in the network security group where APIM is deployed. That's one thing. But of course, this front door service stack includes all front doors in the world, right? So that's not enough, let's say, to make sure that it's only restricted to your front door. So on top of this, you also need to basically verify that the HTTP request header headed by front door contains, let's say, your front door. And then each front door has a unique identifier. And so, and front door will always replace that header with its own value. So if you are, malicious user, you try to put your own, let's say, HTTP header with your own front door, that would be anyway replaced by front door here, right? And so by combining those two, then you know that indeed only your front door can talk to your API. Um, so, of course, going forward, there are some moving parts in API management. You also saw the new tiers, standard V2, and so on. They also have some VNet integration capabilities, but today the only one that is fully, let's say, but today that's also an important thing. So the only one that is fully VNet integrated is the premium, but still, because of front door not being able to see the VIP, you will actually sorry, front door not being able to take a fully private backend if it's APIM, then you will need to expose APIM still. Because typically front door, if it takes an origin that is fully private, you can try to use private link service in between. Right, so you can have, for instance, your front door private link service, and then targeting, for instance, an AKS ingress controller. That works because it's a load balancer behind. But with APIM, it doesn't work. So with APIM, you can add private endpoints today, but you cannot still link front door private link service and private endpoint to APIM. That doesn't work today, which is then, of course, a bit annoying because then you are forced to expose your APIM, let's say, to internet. But again, if you lock it down this way, somehow it's still safe enough. But that's something that, as we say, devils is in the detail. And yeah, you see here that it's one of these use cases where you might say, okay, I'm gonna take my premium fully VNet integrated in internal mode, but that doesn't work with front door today. Okay, so to be followed, let's say, to be continued on to see if Microsoft will change something about this at some point. So
And
yeah,
Stefan,
go ahead. Yeah,
I because we like to give some let's say tips and
yeah,
anecdote from real life. So in the context of the high availability active, I took
mm,
some notes from one session of you wonderful session about lessons learned. And in this first part from door to API management, one of your tips was about the probing with the head
yeah, yeah,
HTTP methods and
yeah, yeah,
for example, creating a health API in
yeah,
API management. Would you like to maybe? I believe that are nice,
yeah,
very interesting
indeed.
one. Just say
Yeah,
something
yeah.
about it.
Yeah, indeed. Yeah, indeed. Before we really move to the real backend, indeed. So still at the level of front door. So when you monitor your APIs, there are two ways. So either you take, for instance, the health endpoint, let's say from APIM. It has an endpoint called like slash status ABCEF and so on. But that actually, if you do this, well, API might be healthy, but maybe your backend is not. Okay, so that's one thing to consider, because of course, when you use the APIM built-in health check endpoint, it will always say about is the gateway healthy or not. not if your backend is healthy or not. And that's actually what you prefer to know, right? You want to know that if your API is down on West Europe, not mentioning the whole region, just your API, that then you want to route maybe to the other region. And so then for this, then you need to monitor the actual health of your API. And so what I recommend to do is typically have indeed an endpoint, an operation, a health operation in the API itself, or a global health where you would have to play a bit with policies to check multiple backends at once. There are multiple approaches. It all depends on how many APIs you have and so on. But the goal here is to say, okay, to not expose this health probe anonymously, because you know that the health probes that cannot make advanced stuff like requesting an access token before they call your endpoint. So either you say, okay, my backend health in the end in my backend service is exposed and you don't want that too much. So one tip that I try to use is to basically use a subscription key just for the health part, because subscription key can be passed as part of the URL. So any health probe is typically able to put a query string, right? So in APIM, you just say, okay, your health is actually this, targeting an operation of your API or a global API for monitoring. And then you can really measure the actual health of your backends. So one tip indeed that you have to do is that should really be a ping, right? You should not actually try to have smart health checks at that level, because front door is almost a DDoS by its own. I mean, it will really hammer your backend with a lot of probes. So if you do something, and I had this, that's really from real world, where the application team was doing a good job somehow. They made a health check, but the health check was really smart, really trying to see if the application was healthy by checking the dependencies. So they had dependencies on service bus, they had dependencies on a SQL database, and so on. And in the health, they were reading something in the database, they were reading something from a queue. But then, of course, if you put front door in front of this and front door sends request to such an endpoint, in the end, it will consume a lot of compute, right? And it will slow down your app because actually you will have a lot of requests going there. So it should really be, if you use ASP.NET, for instance, it has health checks in ASP.NET built in. Just use this and say, yes, I'm there, fine. If you really want them to have a smart health check, then you'd rather use such endpoints for with availability tests, right, from a application insights, for instance, or have a health page where you can say, okay, a dashboard where you can say, okay, I'm calling now the real health of my check endpoint, let's say, of my app, and I have a more exhaustive view, comprehensive view about the health of my app. For a health probe like front door or application gateway, whatever you might be using, always put a ping stuff. And so the tip number one is to then use APIM subscription key so that your health checks are not anonymously accessible over internet. And tip number two, always reply with an empty answer. And you can also use the head verb in your health probes just to make sure that even if the health check is not actually the backend endpoint is not returning an empty answer, then you will not consider the body with the head. And why is that? Because if you take something that has a lengthy body in the reply, then it will also consume a lot of bandwidth and you will pay for it, right? So if you don't pay attention, that's the same for customer where they had the smart health check. They were basically also returning a JSON payload, not that big, but with okay, service bus, okay, database, okay, blah blah blah. But then you multiply this by the thousands of calls that you have per minute sent by front door, and at the end of the day, you have let's say some gigabytes. At the end of the month, some terabytes that are just going over the wire just because of this. And they were of course using a get verb, so which is not ignoring, let's say, the response, if any response. So indeed, that's one of the tips. Let's say that it's a good catch, Massimo, to remind me to talk about this one. So I think so. Again, front door, WAF, driving seat for the load balancing and so on. You can put any rule. Pay attention for the health part. Then API multi-region and possibly zone redundant at the same time. So that's the most robust architecture, but also the costliest. So you also need to consider this, of course. And then in the backend itself, whatever you might be using, right? Typically nowadays, if you would have web apps or you would privatize this, right? Because the goal is to make sure that the only way we can reach your web apps then is to traverse the entire, let's say, end-to-end chain. And then, of course, a data, let's say, service. And that's typically what is the most challenging in Azure. If you have really active, let's say, solutions, then Cosmos DB is a great service for this because Cosmos DB is the only service that has multi-master right out of the box. Okay, so any other option, so even Azure SQL, you can do some stuff, but then you need to have extra tools to actually sync the database and so on. So while here, Cosmos for this use case is a very good option, at least for the multiple region, right? Though it also depends, of course, on what is the nature of data you are dealing with. If it's heavily relational and so on, then Cosmos might not be a good option. Um, and that's it. And once you have this, and also why is that good, Cosmos? Because the SDK as well is very powerful. So the SDK is also itself able to switch. So if you have a backend that is in West Europe, for instance, so typically talking to the West EU Cosmos instance, basically, if West EU is not there anymore, it is able to switch on its own. You don't need to write anything in code. This is just built in the SDK. So, and then that's what I did in the demo in the past, but I cannot do that now because it costs an aircraft to build this. So, of course, when I build it, I have to wipe it out quite quickly. But basically, what I did is that I could stop anything in the chain, and then you could see that the traffic was seamlessly going sent to either the healthy region or healthy backend, right? And Cosmos as well, you can start, stop regions, and then see how your application, let's say, how resilient is your application about this, and that's a very good end-to-end stuff. All of this inspired from a real-world use case where they even have a third continent, right? And billions of API calls per
Okay.
month.
So we are almost
Yeah,
out of time. I would like to recap and just I wrote down one or two questions. We can also go a little bit over
yeah,
time,
yeah,
and just wrote down also something that you just mentioned. Okay, so if you zoom out 1 second, so
yeah.
we
Oops.
saw sorry yeah, so we saw this we talk about this high availability, so
Yeah,
global and regional high availability,
yeah,
so we can have our application that is resilient in case of disaster, so from one region to the
yeah,
other. Wonderful.
yeah,
Cosmos resilient SDK, wonderful. We
yeah,
talk about enterprise grade, so all of this security, I
yeah,
mean hardening
yeah.
with private endpoint,
Path. Yeah,
NSGs,
yeah,
firewall, etc., etc. I have one question. So I would like you to zoom in, for example, in the primary region.
yeah. Great.
So you said, okay, one of the things that you said, you say, okay, I can in some if something goes wrong, I can move from the healthy region or from the healthy backend. So I
Mhm.
mean, I can go to the healthy region or I
Yeah,
can go to the healthy backend.
yeah, yeah.
So now my question here is like in your case, in this because this example is coming from your customer
Mhm,
experience,
mhm, mhm.
my question is like, do you also consider in that API management to use a policy that
Yeah,
might, let's say, route,
yeah,
suppose that something is wrong in the backend of
yeah,
Europe that is on top,
yeah,
it might route from that Europe, of course, to US. In order to do this, you should have your health probe. It should not. I mean, it should be also
yeah.
smart.
Mhm, mhm.
So yeah,
Yeah,
why to do this? Because the why is that I see is like if you want to reuse that API management capacity in
mhm.
terms of resources, right?
Yeah,
So, but
yeah.
is it a clever way? It doesn't make any sense. What is your opinion on this?
No, it makes sense, but in that case, for instance, for that specific use case, the customer had plenty of API calls, but not plenty of APIs. So actually, this health probing approach and letting front door, let's say, in one health check at the level of so a global actually health API that was checking the three backends they had was good enough. No, of course, indeed, you can use policies, indeed, in APIM to say, okay, if that backend actually fails, so then send it seamlessly to the other backend. So either cross-region, either even within a single region, right? Because if you have, for instance, 3 zones, you will typically have at least 3 instances of the backend service, and maybe one of them might be unhealthy, and you would like to maybe then try something else. No, it's of course a bit more complicated, right? Because then you have to write in those policies, but you have all the tools that are possible to do in APIM, because once you're in the context of the policy, you will see which regional gateway unit has been invoked, let's say, and then from that you can of course decide stuff. Say naturally, anyway, you have to use policies. We don't see it here because it's a diagram. I was showing that in the live demo. You need to have a policy. Yeah, we see it here. The set backend service, because indeed, when you have the West, for instance, West EU backend that is invoked, well, the West EU backend, if you have APIs that are mirrored into different regions, it doesn't know where to send traffic. So it's up to you still to anyway tell, okay, if you come, for instance, from West Europe, then pick up the West EU backend. But indeed, you can go further and say, pick up this. And if it fails, silently yourself through policies, then invoke the North US backend. So actually, it's even not mutually exclusive.
Yeah,
So
yeah.
I would say,
So,
you see, because you could actually combine both.
yeah, you can combine the load balancing policy plus the circuit breaker also to go the extra
Yeah.
mile. But
Yeah,
like I love the simplicity and how effective is at the same time very secure this setup. So I have one more question. Anyway,
yeah.
we are running out of time, but
Oh,
we
it
can.
doesn't matter.
So my
Yeah,
question is like is about the egress from that API management.
yeah. Mhm.
So do you normally go via firewall for the internet traffic? So here
Yeah,
you picture
yeah,
the private
yeah,
traffic
yeah,
within
yeah,
your network.
yeah.
Yeah,
Yeah,
something like that.
look, here it's in there. And so here I put it in red because for the demo I made in the Microsoft session, I did not put the firewalls there because I told you it costs already an aircraft just with APIM and so on. So adding firewall cost to it. But indeed, typically you would also do this, right? And that's also a benefit of still being VNet integrated for the, although you have, if you take front door, you must be internet facing for your APIM. Still, indeed, APIM itself is talking to, let's say, private backend. So you need to be VNet integrated anyway for this. But then, of course, you indeed can control traffic. So typically, egress traffic, that's what I put here, you see. So the zero
Yes.
zero route would actually go to a firewall. So either Azure Firewall or what is called Network Virtual Appliance, and you would do that because indeed, pay attention, although APIM has dependencies to storage and so on. So it depends on which firewalls you use. If you use Azure Firewall, that's also anecdotes from the field. If you use Azure Firewalls, you have the service tags. So that can be helpful to whitelist, let's say, the dependencies of APIM. If you use, let's say, Palo Altos and the likes, you can actually import the Azure Service Tags, but it's you need to do some homework before you can do this. And if you don't have the service tags, then it's almost unmanageable. So then you might be forced to say, okay, for instance, like here I did it for API management, next up internet. That's required. That's otherwise you break APIM. I will not enter into the details. That one is required, but you might also say for the Azure, the APIM dependencies, that you do a next hop internet route as well for these dependencies. If you are using Azure Firewall, you can send everything to the firewall except this one, right? The API management, because that's control plane traffic. All the rest can be sent to a firewall. And you try to do this. And why? Simply because API management, you can write policies, right? So I can write, if I'm a malicious insider, no, you could have mitigation actions there, but if I'm a malicious insider, I could craft a policy that is actually exfiltrating data to a storage account of mine. If I have an extra route internet, or if I just take the default, meaning the default internet route that is available, made available by Azure, then with such a policy, I could actually send stuff to my own stuff in my own Azure. Of course, I need to be a malicious insider. You might have a good review process to prevent this kind of stuff, right? With pull requests for rights principles and so on and so on. But let's say the risk, if you want to see really what's going out, then of course the firewall remains, let's say, a possibility.
Okay.
Okay, good.
Yeah, that's very good. It also saves you if you have a lot of traffic going to a single IP,
Yeah, yeah,
and
the snap port
you're
exhaustion. Yeah, yeah, indeed.
over from the snap problem
Yeah,
and this kind of things.
indeed,
Okay,
indeed.
Wonderful. I think that it was a lot of nice content and a lot of nice tips from the field. So I would like to thank you, Stefan, and thank everyone that is joining or is watching these episodes. So voila, we are at the end.
Thank you too, Massimo. So talk to you soon. See you guys.
Bye bye. Thank you.
Bye-bye. Bye.